Okay. Hey guys, I'm pretty sure I'm live now. Cool. So yeah, this session is actually being done purely online, and just because we understand that it's Ramadan and this coming in person is a little harder, so we decided to do it online. So this is only being streamed. I hope I'm audible. 1 second, let me just see how stream is doing. Cool. Okay. So welcome to our fourth installment in the Unity series. This will be not an introduction, but we will still cover a lot of basics. But what this will be is an improvement of our previously made 3D controller. By controller, I mean like a set of or a framework and scripts that let you control an FPS, camera, and player. So, like I mentioned before, this is the fourth installment in the series. I do recommend you guys check out the previous 3 ones. They are in the link of the in description of the video. So, what we'll be doing in those previous ones, I focus more on the basics because we start moving our way up. Don't worry though, so like you see here, we'll still have a recap on Unity, famous examples that we use, how making a project works, what your basic screen layout is, and then finally we'll move on to the test demo where we actually make our 3D controller. So just a little bit about the assembly, what we do and who we are. We're a smart lab in Makerspace based off of In5 in 2014, that's in Knowledge Village here. We have over 350, and above, it keeps increasing each week, free workshops that we do, and this happens on a weekly basis. We focus on smart technology and practical applications of those, of new and upcoming tech. So we have 3 main types of workshops. We have hack, which include embedded systems, IoT, hardware, stuff like that. Code, which is what this one is, software, APIs, frameworks, and apps. This comes under technically frameworks and a bit of application development. And then we have data science, which covers like advanced topics in AI and machine learning. And now we've also been doing a lot of entrepreneurial stuff. So our audience ranges from students, professionals, entrepreneurs, anyone you name it. So we're open to all. You can find us at Make Smart Things. I don't know if you can see it. Or at www.theassembly.ae, which is our website. So let's go to a recap on Unity. Just in case you guys haven't already, this is Unity. This is what you guys will need to install. Normally this is a link, but you'll have to type this out on your search bar URL. So okay. As well, we have not the entire project, but everything that you would need to get the project running is on this GitHub QR code. So scan it, and that's how we'll go through the script. I won't be live coding this as it's pretty long, and it's a waste of time. So instead, what we'll do is you scan this, and I'll go through the code that I've already written. Now, so let's start off with what Unity is, what it does, who uses it, stuff like that. So Unity is a game engine, and what that means is essentially it's a framework or an application used to build and make games. So obviously this is used by a lot of game studios, not necessarily AAA titles, things like Call of Duty and stuff, but a lot of other, or at least a lot of people use it as a stepping stone to get into game development. It's a very strong and very powerful engine, and obviously you need to write code to get games run. It's a video game, so in terms of that, you use C# for scripting. So any code that you would write and anything that you would do, Unity compiles in C#. Similar softwares, so other game engines include Godot, Unreal, and Game Maker Studio, which are these here. So why Unity then? If there are so many like popular ones, let me go over a bit about each one. So Unreal Engine is what you would use if you want to make a lot of realistic 3D games. So not necessarily stylized things like that have a very cartoony look or very personalized experience, but if you want to stick to like realistic graphics, and if you're making a very large intricate game, then people tend to use Unreal Engine. Not to say that these types of games aren't made on Unity, but majority of them are on Unreal. It uses C++, so it's a level below C# in terms of abstraction, which means it's harder, and it is a harder engine to use. It's a lot more small things that you have to, like the learning curve is a lot steeper. Then you have Godot, which is specialized for 2D game development, specifically pixel graphics, and like most 2D games in general. This is a very simple to use game engine. It is designed to be very easy, but because of that, kind of like with programming languages, there's a lot of unnecessary things that happen that decrease optimization or decrease performance. So if you're making a very large game, then Godot isn't recommended, because sure, it's easy to use, and it also uses its own proprietary scripting language, which is GDScript. It is very similar to Python, sort of. So it makes it easy to use, and it is very easy to use, and you can use it for a lot of applications, and it's a good place to start. But it also limits what you can make if you want to scale up your project. And then you have GameMaker Studio, which is a very mediocre, like it still works, but it's a very legacy. It's a legacy piece of software. So and it was one of the first. So a lot of things that it established are now like the norm that other game engines use. So because of that, a lot of people that do use it, they use it because they grew up with it. This is what they're used to. So why do we pick Unity? Because it falls, if Unreal Engine is the hardest and Godot is the easiest, Unity falls flat in the center. That's because, while you can make very large scale applications, it's also pretty easy to use. So it's a good middle ground for both. So hence why we're sticking to this. Now let's look at a few games that aren't necessarily built entirely with Unity, but Unity does play a hand in. Altikill, very, very, very stylized game. It's meant to, even though it's a very new game, it looks dated as that was the intention. It looks like those old retro arcade first-person shooters. Then you have Apex Legends. I'm sure it's a pretty big game. Doom Eternal, another thing that exploded when it came out, very, very fluent with its movement, and that's what we'll be focusing on. So if you know these games, then you might see or notice that they have one thing in common. They have very fluid movement. So obviously FPS is just one genre. Within it there's so many different kinds of things that you can make that personalize and customize your game. Now this specifically is what I'm trying to make is a movement shooter. So what that means is you have a high emphasis on movement as a tool. So it isn't just a thing that lets you get from point A to point B. It's also something that you can use as a very core mechanic to the game. So for example, just throwing out ideas here, there's an enemy on a really high ledge. Sure, you could just like shoot at them perhaps, but that makes for a very unintuitive game design, and it doesn't really. Height advantage is a very common tactic in these games. So if you'd want to role play that scenario, just being able to shoot them back isn't very immersive. That's the right word. So what you do instead is make use of the movement that you have, perhaps wall climbing or jumping enough to reach the same height, and it makes the whole experience a lot more, like I mentioned earlier, immersive. So let's go to actually creating a project in Unity. We'll go over downloading a stable Unity editor. So what I asked you guys to install earlier, and what you should have by now, is Unity Hub, which is basically a suite of. It's the creative, or it's the Adobe Hub to all of the Adobe apps. So The Unity Hub allows you to manage the different versions of the Unity editor. As you may know, building a game takes a lot of time. So what happens is, over time, the editor that you're using might be updated. So while you're working on your project, things may change, and you'd ideally want to stick to the latest version of the Unity editor. So Unity Hub allows you to smoothly transition from one version to another, because you don't want to break your game just because you updated Unity and now everything that you worked on just doesn't work and you have to rewrite everything. You will have to rewrite some stuff just if they make major changes. That's just the nature of it. But Unity Hub lets you manage those things a lot easier. I'll explain what modules are. So modules are basically the different platforms that you can use. So Unity as an editor can be used for mobile app development and like PC or console app development or PC games. By default, it lets you only build on PC, Windows, and Mac, if I'm not mistaken. But that's specifically for that one thing. If you want to make a mobile application, you'll have to go and install an Android or Apple SDK. And then we'll go over creating projects and project location. I'll show you. So this is what. Give me a moment. Okay, so this is what Unity Hub should look like. You won't have a list of games, obviously, or different projects, but this is what it looks like for now. If you go under installs, you'll see the different versions of Unity that you have. For now, I only have one because that's the version I'm using, and this is the version that I recommend you guys use as well. You can use any version of this or higher, so it's okay, because the project that I made is compatible with this version of Unity, so it'll run regardless. These two you can just ignore. Cool. So if you go under projects, click new project, and it'll take a while. So what you have here, that's the screen here. So here you'll see your version of Unity that you're using. You can change that if you'd like, depending on what kind of project you want to make. Maybe you, for fun, use some legacy tools. LTS stands for long-term support. So the latest version always will have long-term support as well as any of the core releases. But every now and then they'll have a experimental beta version, which means that not all the bugs of the editor itself has been sorted out. So while you might have flawless code, the editor itself might have bugs and issues. So unless you're very confident with Unity, I don't recommend using anything that's non-long-term support. So you'll have the different templates here. What are templates? Unity, like I mentioned earlier, is a framework. So you could have your project set up to do any number of things, but setting it up each time takes time and a lot of resources. So instead, what Unity does is it hands you some templates here. The core ones are 2D, 3D, URP, which is a universal rendering pipeline. Again, we're not making a full-fledged game, so you don't have to worry about that. But this is what is, the universal rendering pipeline is commonly used. AR, this is what we did with our last project. Today we'll be going with 3D, obviously, and it'll set your project up so it's streamlined for 3D projects, because your camera can change, what basic resources you use within a scene. I'll explain what a scene is. It's all customized to 3D. Here you can specify your project name and where you want your project directly to be, and then you can just click create project. I already have the project, so I won't be doing that right now. So this is what it is. Cool. All right. Okay. So most likely you're not going to see something that looks like this. This is the completed project, so you already have all these things in it. Just a moment. Okay, 1 second. Do you want to sorry Meeta, do you want the link shared with you? Because the Unity Hub link, sure, I can put it in the, just in case. Just give me a moment. Sorry, there's a bit of behind the scenes stuff going on here. Cool, you guys should have it now. Okay. Sorry, going back to this. Okay. So you're going to see something a lot more different. This is maybe not exactly this, but you might see a 3D version of this, and it'll be very bare bones. You'll have two objects, or actually just one object, a main camera, maybe perhaps a directional light, and that's it. So let's go over what you're actually looking at within the screen. So, okay. First, what you see here is the file tree. So all the files that comprise your project, they'll be all visible here. As you can see, they're in different folders, and you can arrange that. Whenever you're accessing different files and stuff, this is where you'd go. Then you have the expanded view here. Now, this isn't the official term for it, but this is what I like to call it. Right now, what it shows you is the expanded view of the file tree. So here, for example, my bad. So I have a scripts folder here, right? Within that, I can see all of the script files, and they have a little icon that shows me what kind they are. If I go to, let's say, materials or mats, I can see the different materials that I have here. And within assets, I can see the different folders themselves and the actual scene itself. So that's what the expanded view is. Now, that might sound redundant, right? Why have a file tree and an expanded view? Two reasons. One, oftentimes you will have to name your file, the two files, the same thing. So, for example, you have an animator and an animation in Unity. So even though they're different file types, they would need to be named the same thing in order for Unity to pair them up. So you'd have running.animator and running.animation. Now, if you were just looking at words and names, they don't show you the file extension, so you won't know that they're two different files. You won't know which one you're clicking on. So the icons help with that. They have different icons, and they'll show you what exactly to do. One second. Just a moment. Cool. Okay. Let me yeah, there you go. Okay. Okay, so that's the expanded view. It shows, but the second reason, so I mentioned there was two earlier. First being, it just lets you get a quick glance on what file you're looking at or what files you want to use. The other reason that you may use it is to So the expanded view is just a place you can dock your window. And what I mean by dock your window is here. So for example, you have the project and the console, right? If needed be, I can grab my inspector and put it here as well. And now I have this entire space to inspect an element. But that isn't normally what's done. So one second. Cool. Okay. So that's it. Normally you don't put the inspector there, instead you'll put your animator or your animation timeline and put it here and stuff. So it's an expanded view for whatever you may want to look at. Then you have the object hierarchy. This is where you'll see all of the objects that comprise your scene in a hierarchy tree here, similar to your file tree. So what a scene is, so they use theatrical terms to describe this. A scene is what's in a level. You can think of it as a level of a game. So in level 1, this is what my scene will look like. Maybe level 2 will look different. There'd be different objects around, different views and stuff like that. So it changes depending on what scene you're looking at. Within that scene, I have all these different objects here that do different things, and they'll all interact with each other within the scene, and that makes up my level. So that's what it shows you. The next is the viewport. So you have two versions of the viewport. You have your scene and your game. So viewport is where you can see all of the stuff that's in your scene. This is a visual representation of all the objects. Like for example, I have a cube here. That's that cube there. These are slopes. That's my slopes there. So they all have. Sorry, one second. They all have a visual place for these things. This is the scene view. The game view will look like this. Now I can't move it right now because the project isn't running. But what that means is, so in your scene, you have all these objects, and one of those objects is your camera, right? Your camera is what your game would look like through the lens. Your camera is the lens that your game is going to use. Think of it that way. So, whereas the scene view is what you would see backstage and how you would manage all of the things within a scene, if we're using theatrical terms. The game view is what the viewers would see. This is how your players would play and interact with the game. This is what it'll look like. The reason it looks like this is because I put my game. Sorry, here. I put my camera on my player. So right now, this is what it looks like, and here's the shadow of the player. It's inside the player. Next, you have possibly the most important part. This is where you'll be doing majority of your work. This is where a lot of things happen. So what happens here is each object is comprised of different components. Now, C# is an object-oriented programming language. I'm sure you guys know what that is. And anything can be described as an object. And those objects have different attributes to them. So the equivalent of that in C# is components. For example, okay, one more thing. An object behaves differently based on what components it has inside it, and like how those components interact. For example, let's look at this directional light. Okay, so it's an object that has two components right now. A transform component that allows it to move in 3D space, rotate, change its scale, whatever it may be. And then you have a light component, as you can see here. Now the light component has all these different things that you can change, all these different settings. You have what type it is, so it can be a spot, which is just a point, not a point. A spot is similar to a point, but they differ in how they're rendering. Areas, a whole different thing, and directional shoots rays of light in one specific direction. So we're using a directional light for now. Then you have the color of the light. You can change the color if need be. For example, I can change it to a very saturated yellow, green, whatever it may be. We'll keep it as this, as it's a very natural. This is what sunlight is colored like, my bad. You can change its intensity and all these different things. Now, I won't cover what each of these do simply because it's a menial task. Having to learn all of these things before we even use them doesn't make sense. So as the use for something comes up, I'll show you what it does. And you can do your own research with Unity documentation. Unity is beautifully documented. Any questions that you have, they will be answered if you simply just do the lightest Google search. You don't need to know what all of these are, so we can just move past it. Okay, so in our previous series, or in one of our first episodes, we covered 2D. 2D is a little simpler than 3D, as you are literally working with one less axis most of the time, the y-axis in this case. So here is your primary difference. So this is your gizmo that lets you view in X, Y, and Z. So here I can change what perspective I'm looking at. Now it might be confusing. You guys might potentially be used to X and Y being the 2D and then Z being the third dimensional coordinate, but over here axis, sorry, but here it's different. So X and Z are your 2D and Y is your up and down. So X is left and right, Z is back and forth, and Y is up and down, just to make that clear. And you can change how you view your camera. You can just snap to different. So you can freely move by holding down right click and dragging your mouse around. That'll change what you're looking at. So you'll rotate around a point there. But say I want to get a top-down bird's eye view. I can just click this piece here and I'll get a top-down view. You can zoom in with your scroll wheel. And now so navigating the space around you in 3D does take some getting used to, but it becomes second nature eventually. These are the key tools that you'll need to know. The pan tool, which is Q, the rotate, which is right click, I just showed you earlier, and your XYZ gizmo, which is this thing here. So I can switch between the different axes, anything in between, I can get different views. Now if I hold Q, if I press Q, as you can see, it's changed its selection here. Now I can move wherever I want, so up, down, left, right. If I want to zoom, I can zoom there, and if I want to rotate, I use right click for that. Now while holding right click, you can use the W, A, S, and D keys to move around like you were flying around. So if you hold W, you'll move in the direction that you're looking, as well as you can infinitely turn. So your cursor will automatically wrap around to the other side. So another thing that you can do is if you click player and then move your mouse to the viewport, hit F and it'll focus onto the object that you clicked on. So here I'm focusing on the plane, my camera, I can focus onto that here, or if this particular cube. So whatever rotation I have, I'll focus onto that. Pretty simple stuff. So let's go back to our player. Okay. So that covers the basics of Unity. You can always look into scripting and how each of these things work. This looks like a lot, I know, but as we go through it, it'll make a lot of sense, and it's simple. This just allows for a lot of customization. So if you want to use it for a different game, you can. Cool. So first thing that you want to do is go to File here. 1 second. Oh, sorry. Second, no, my bad. Edit, there we go. Edit, project settings, go to, where is it? Graphics, package manager, time. Make sure that your time settings are the same. So they should be. So what these settings mean are basically how fast or slow, or the rate at which time progresses in your Unity project. So if you want to slow something down, you decrease or increase the time, so things take longer. and vice versa. So if you go to physics, where is physics? There we go. Make sure that your gravity is set to -30. We do this because the default gravity that's in a project is a little too floaty. It doesn't feel fun to play. So here, for example, let's demo what this is like. So if you click this play button here, it basically lets you test out your project. So you can, as the scene is set up, it'll let you play around here. So this is what my project looks like. Here I can perform, I can move around here, I can crouch underneath, walk here. We have a little space for testing jumps, so oops, I missed. So things like that. So you can move here. We have different slopes at different inclinations that let you do different things. So one of the bigger things that I'll be covering is sliding here. So one thing that you can do is you can slide around. So it's difficult to see because you don't have a point of perspective, but you can jump, crouch, and slide around. Those are your main things. Another thing that you can do is conserve momentum. So if I'm going down here, you'll see I start to get faster, and I can conserve my momentum and move at really high speeds, and then slowly slow down as I go through. So I'll teach you how to make these things. This here, I will be eventually implementing jump pads that let you jump on top of this, but this is just, so first things first, let's teach you how to make this environment. So here, so if your mouse gets lost, just hit escape and the mouse should come back. Here, okay. So the gravity here lets you feel, it feels more naturally, not like bouncing off in the air like you were in the moon. That's what your normal gravity is, hence why we use -30 as our Y gravity. Okay, so let's set the scene. Let's set up the scene. So first we'll make the floor and all these other interactable objects. Okay, so what you want to do is in here. Okay, so right now we have a pretty bare bones. You guys should have a very bare bones project. So all you'll have is your directional light and a sample scene and perhaps the main camera here. So these two things within your sample scene. What you can do is hit right click, go to create object, 3D object, and then plane. Okay, once you make your plane, this is, oops. Okay, so now how do you move this around? Here, so these are your other gizmos that let you navigate in your 3D space. So Q is for pan, W is to move. Okay, so you can either click these or you can use QWERT. So that lets you switch between these quickly. I recommend learning the keyboard shortcut just to make your life easier. Cool. So what the move tool does is it lets you move an object in that axis. So these, if you hold on these handles here, you see no matter how much I move my mouse left or right, it's not going to move. It's only going to move up and down. Likewise with this, I can move it up and down, and nothing. It's never going to change its Y coordinate, only X. And finally, the blue one here only lets change it in the Z coordinate. As well as that, you can also see these little squares here. That lets you move. Okay, so this is going to sound a little confusing, but it lets you move an object in all axes except the color that it is. So for this one, for example, here, I can move it in X and Y, but not Z. Does that make sense? Here, I can move it in Z and X, but not Y. So the Y coordinate will never change, but I can move it there. Same thing with this, I can move it in the Z and Y, but not in the X. So no matter how much I want, I can't move it sideways. So once you do that, if your plane is perhaps in a different orientation, like for example, it's 90 degrees like that, then what you want to do is change. So you can so right now I'm on the rotation tool, which is E, and I can rotate it within those three axes however I'd like. Or what I recommend is just changing the rotation here. It's a lot more precise, and so what you want to do is, okay, first 0 everything, and then change the, okay, it's, so by default if it's 0 it should be like so. One second. So it should be that, like this, and you just want to make it big enough to become the floor of your level. So what we're making here is the floor. Now to change how big it is, there are two ways. You can use the scale tool here. So let's look at it from top down. So we have a clear view of how big things are. So if I hold down, if I press R, I can go to my scale tool, which lets me change the scale in a certain axis. So this is the X, this is the Y. I don't want it, it's a plane, so it's never going to get thicker than 1 unit long, so you'll never change that. So I can make it a square here, I can make it a 2 by 2, 2, or if I hit T, or if I go here, I can choose a rectangle tool, which lets me do the same thing, but it's more for cubic shapes. So if you don't have a if you don't have a cuboid or a square or any quad, for example, for that matter, a rectangle tool is not as useful, but yeah. Either way, make it big enough to where it covers this amount of space, roughly something like this. Wait 1 second. So this, I made this 13, like in all axes. So you can do that. Make sure it's at position 0, 0, 0, just to make things easier. Let's go here. Okay. Then what you want to make, next thing that you want to make are these platforms here. So these platforms, we're going to use them to test out jumping. The reason they're in a curved shape instead of just a straight line is so you can test out air strafing. So you want to be able to move while you're in the air. Obviously not to the same degree as just walking, but you want to be able to have some degree of air control while you're either free falling or you've jumped. It's not realistic, but it's a core part of games, as things will feel very clunky if you don't. It's a balance between reality and game. Additionally, there are also, 1 second. So as you may notice, 1 second, they're at different inclinations, so you can test out that as well. So how you can make this is, again, same thing, right click, 3D object, okay. So yeah, 3D object, and make a cube this time. Okay, my cube's a little far away. Let's change that. So here, I have my cube here. Then what you can do is just change its scale up a bit. So I don't need it to be this thick, so I'll just go to the scale tool, make it a little flatter, make it bigger so it's like a proper platform I can stand on. And then you have your platform here. Then from there you can simply, if you click the center, you can do it in all axes. So that's what I did with this initially. That's why they're symmetrical. Then once you do that, let's go back to the Y again here. Okay. So once you do this, you can you can just hit Control D, and you'll duplicate that object, and then you'll have another copy, and you can keep doing that, and each time change its rotation just a tiny bit. So in the y-axis. So, and then you'll change it up, so you have this curve pattern here, and each time move it slightly higher or lower depending on how you're setting up your scene. Okay, and then you'll have these 4 objects. The next thing that you want to do is just set up this big block here. This block here. Same thing, make a cube and make it big, however you like it. You don't have to copy this exact layout of the scene, but just something that's close enough, a close approximation. Then to make this tunnel here, so here. So I have a tunnel here that's these three shapes basically. So what it is, so here, it's comprised of three, well, it's labeled cubes, but they aren't cubes. You'll have the top piece here and the two leg supports. Again, same thing. What you want to do is make a cube. Here. And then just change its scale depending to what you need. So the legs would be long like that, and then you duplicate it, make another one. The top would be a little thinner, but a lot wider, and then you have your tunnel. And then what you can do is you can do create empty. You create an empty object that has nothing but a transform component on it. The transform component is a little unique, as every object must have a transform component to exist in a 3D space, because otherwise, if they don't have a coordinate that they can use, then where do they exist? So that's the only reason you'll always have a transform component. But this has nothing else, so hence it's an empty game object. Then you can take your cubes and, sorry, my bad. Here, if you hit F2, you can just rename it to large block, for example. Okay. Then this cube that I have here earlier, there's a big cube, I can move it inside this empty object. So now everything is grouped together. So that's what I did with the tunnel. I can just simply move it back out. Yeah, move it back out and just delete the large block. Okay, so this tunnel has all these three objects grouped together because it's an empty object with three cubes in it. Okay. Oh, and lastly, you have these slopes, which is the same thing as before. Make a cube, make it really flat and thin and like slope shaped, and then change its rotation. So I have one starting with -10, then 20, 30, and then 40. So in increments of 10, and you'll have this. You'll have this shape here, and then I also have a platform here, so you can stand onto it before you start ramping down. So yeah, and that's your basic scene setup. This might take some time, but because it's a live stream, you can always go back, pause, and wait. But I'll be moving on. Okay, 1 second. Okay, let's move on to making your player. Let's minimize all these things. Okay, so now the player itself is actually an empty object. So the object that's named player is an empty object. Within it, you have three other objects, which is capsule, which is what gives it this shape. So to make that, you do 3D object, or rather you'd right click player. So to make the player, again, create empty, okay, name it player, then right click the player, 3D object, capsule, and they'll automatically make this, which is your player's body. Okay, so it's going to have mesh filters, which basically gives it its form, and then the collider. So objects in Unity will not interact with each other, so you can think of them as like ghostly objects. They'll just simply pass through each other unless both of them have a collider. A collider is the physical boundary of something, not just the visual boundary, a physical boundary. So this is what will, like if you threw this against a wall, this is what stops it from just moving through. It's colliding with a wall. Now these walls, so this one is a capsule collider that goes around the form of this mesh. So the mesh is the visual boundary, and the collider is the physical boundary. Okay. Just a moment. Let's see. Okay, the two other ones that you'll have is orientation. Again, this is also an empty object, but just label it orientation, that's it. And camera position, same thing. Camera position, you'll have it slightly higher. Here. So you basically want it at the top of your player, because the capsule that we're using is just a stand-in for what you'd normally have. You'd have an actual 3D model of a character, but going into animation, sound design, and the model of a player, that's something very advanced, so we'll look into that a little later in future sessions. For now, just to get movement going, we don't need any of that. We just need something that will act as our player, and that's what the capsule is. Orientation lets our camera know what way or what direction our capsule is facing. Then lastly, you have camera position, which I'll explain what that is in a bit. So you guys will have your camera. What I want you to do is make an empty object named camera holder, and then attach the camera to that camera holder. So this is a container for the camera. Now the reason we don't want to just make a camera is because attaching your camera to your player will result in a lot of bugs. So your camera and your player are two separate things. They don't necessarily have anything to do with each other. But oftentimes in an FPS, your camera is your face, hence the first person nature of it. So what you'd want to do is you want your camera to follow wherever your player is and wherever it's looking. So that's what we're going to implement now. Okay, let's go to scripts here. So if you guys have the GitHub link, which you should have, you can go back and scan the QR code, or if anything, wait. Yeah, you guys can view it through there. Yeah. You can check the GitHub link, and you can go to the improved 3D controller, or something 3D controller. Player. Okay. So we have two scripts here, a move camera and the player cam. So first look at the move camera. It's very simple. Very simple script. So when you open it, you should have a start function and an update function. Remove both of those. What we're going to do is we're going to have a transform of the camera position here, and on void update we'll simply make the position whatever the camera's position is. So what update does is games run in frames, right? Each frame a certain action will happen, and until the next frame nothing. So it's like, for example, our object is here at frame 1. If it's moving at frame 2, it will be here. Things like that. So update is a method that's called each and every frame. So our games run at 60 frames per second. At least that's a default for Unity. You can change that and modify that. Console games typically run at 30 frames per second. So there's a difference there. But what this does is basically makes the current position whatever the camera's position is. And now what's the camera position? That's where? So here. So the camera position, this is where you'd add this piece here. So what I want you to do is, after you write down the script, or if you just copy it through GitHub, that's what I assume you're going to be doing. So you're going to have this public transform here, which accepts an object's transform component. So what you're going to do is go here, go to camera holder, go to add component, and search move camera, and that's a script that you just created. It'll act as a component and you can add it. Then once you add it, you should have an empty part here that says camera position. Drag this object that you labeled camera position that's under player and add it here. Okay. If you've imported the whole project, this should already be done for you. Okay. Now Now the first thing that we're going to cover is looking around. So obviously it's an FPS, right? So we need to get this working, just looking around and stuff like that, looking up, down, left, right, being able to rotate in 360 but not up. So you don't want to be, so on the x-axis you want to be able to rotate freely, but on the z-axis you want to be limited to up and to 90 degrees up and 90 degrees down. You don't want to be able to look like bend over backwards and look what's behind you upside down. So to do that, we're going to look at the player cam script. Okay, it's a little bigger, but it's still super simple. So what you're going to do is, go hit right click here, create C# script under the assets area. So you will be here in the assets, right click, create C# script, and label it whatever. In this, label it anything relevant. In this case, I'm labeling it player camera because that's what it is. It's a camera for the player. And then once you do that, you can just open it. You'll have start and update. You can remove that and add whatever code is required. Just delete this for now. And a good etiquette, though it isn't functionally any different, it will help you if in larger projects, is organize your things. So you'll have a scenes folder. What I did is I made, so under create, you can go folder and add all of your scripts under one folder. So it just makes things much neater. So under scripts I have all of my scripts and then add it there. So this is what your player cam looks like. Okay. Here, I'll remove all of that. This is what you'll be adding. Two variables that change your X and Y sensitivity, so you can change that based off whatever you need, and you can set that within the editor itself. Then you have another transform that accepts an object's location. That'll change, this will determine what direction your player is facing in, and then you want X rotation, okay, Y rotation, which is here, and then mouse X and mouse Y. I'll explain what those are. So within your start function, so first make a start function here. Oh, I should describe. So start and update are two special functions, as you might have seen in the boilerplate thing that was already made. Start is called once when the game is run. Okay, so at the very start it'll happen once and never after. Update is called every frame. So at the very start, what you want to do is we want to put our cursor in a lock state. So you'll do cursor.lock state equals lock mode. So I'll just put your cursor in the center and keep it there. So your cursor is always at the center of the screen. Then you want to make it invisible. That's why when I hit play, 1 second. So right now you can see my cursor. That's because in Unity editor sometimes you want to be able to switch to different things, so you can still see it. But as soon as I click in here, it's disappeared and now it's locked to the center. Obviously you can't see it because it's invisible, but so it doesn't obstruct your view. So this is what it looks like. If I hit escape, I can see it again, and then just there. Cool. Cool. Now what you want to do is in your update function, you'll make a rotation. So every time it'll check what and assign whatever your mouse's X and Y position is to the rotation. So it works. It's a little confusing, but that's just how Unity handles its X and Y movement. So what you want to do is Y rotation is equal to mouse X. So you'll keep adding mouse X value to the Y rotation, and the X rotation you'll remove it. So minus equals to, so from the mouse Y. It sounds counterintuitive, but this is how it is. Just stick to it. Now, normally you'd be able to rotate in the y-axis infinitely, just like you could rotate 360 in the x-axis. You don't want to do that. You only want to be able to look max straight up and max straight down. So that's where the clamp function comes in. So what you want to do is your x rotation, you want to clamp it or limit it to only 90 degrees. So you'll do, for your x rotation, mathf.clamp. So it takes in three parameters: what you want to clamp, the minimum, and the maximum distance. So we'll do 90 degrees and negative 90 to 90. Then whenever you are applying rotations to anything, you use quaternion.euler, which is just quaternion is what you use for any rotations. It's part of Unity scripting. You can read that in Unity's documentation. So you'll have your X, your Y, and you don't really rotate your camera in the Z axis, which is tilt, so we're not doing that. Likewise, so when looking up and down, our player is not going to physically move their head because it's a capsule, but you still want the whole player to rotate in the X direction. So that's what this is for. So orientation to rotation, and then quaternion.euler, and you'll only specify your Y rotation, which is your X movement. It's a little confusing, but yeah. Late update is a function that's called right after update. So if you want certain things in update to happen first and then only have other things happen, this is where you do it. Then you'll just get your inputs. So this part here will just get the inputs of your mouse and map them onto actual inputs. So here input.getAccessRaw, again just copy these things. Time.fixedDelta time is just a certain type skip. Remember in the very beginning of the project I showed you the time data. That's what this is. And yeah, once you have written this, just save it and close it, and you should have a little compiling happening here. Once that's done, go to your main camera, add component, and search player cam, like so, and then add it. And then simply set the values. So I went with 200 cents, 200 in the X and Y direction. You can make it more or less up to you. And under orientation, I take the player's orientation here and put it here. Okay, so it lets me rotate the player to look around. So it's not just the camera moving. Like, so if you had a fully fledged model, the equivalent would be you're looking right, but the player's face is still looking forward. Think, for example. So it lets you rotate in that degree. Okay, now that we've gotten camera movement down, let's get actual player movement. Let's get to the actual player movement. Okay, before that, what I need you guys to do is add a rigid body to your player. So it was previously an empty script. Search, go to add component and search rigid body and add rigid body. Not rigid body 2D, because if you do that, nothing will work. Because this is a 3D game. Make sure you add a rigid body and stick with these pieces here. So these two settings are important: interpolate and extrapolate. Now this part you don't need to worry about. Collision detection, however, is important. So you have four different kinds: discrete, continuous, continuous dynamic, and continuous speculative. What those do is the different forms of detecting how collisions work. Discrete is very simple. Each frame, the computer will simply see the coordinate of where your object is and see if it's hit something. If it has, it'll return true and it'll collide with the object. But what that does is, sometimes if you have a lot of very fast moving objects, for example if you have a wall here, okay, your object normally would it'll calculate if it's hit anything each frame. But if it's moving particularly fast, sometimes it's starting to its position at point 1 will be here, but at point 2 it would be here, right? Because it's moving so fast within each frame. So what ends up happening is now the computer doesn't know that it's hit something because it's already here. There's no space to travel in between. So it just sometimes you can miss certain collisions between two high-speed objects, between specifically a moving high-speed object and a stationary object. Continuous is, but it's very but even though discrete is not as accurate, it's very resource light. So it doesn't take any computational power, and hence is what you use the most. Continuous is a little more resource intensive than that. What it does is each time, each frame, it'll shoot out its collider a certain distance, see if it hits anything, and then only decide if it's collided or not. Now what that does is, so for example, if an object again was traveling from here to here, it'll first check, okay, I'm going to shoot out a ray from this object and project my, or make a continuous path of my object. Oh, I've hit something. Okay, so in the next frame, I'm going to instead make its position here instead of here and collide with it. Continuous dynamic is very, very resource intensive. You rarely use this, and it's specific. It's the most. It's the rarest of them all. What you use it in is, it's essentially very similar to very similar to continuous, but you only use it when there are two moving objects. So if you have two objects colliding with each other, that's what you check. Continuous speculative is also the same thing, but you use it for rotational. So if something is rotating and hitting an object, a moving object, then what you want to do, it does the same thing. It speculates where its next position would be and if it would hit it. If so, then it would interact with that object however it may be. You can look at more videos to see how discrete, continuous, and all these work. For now, we'll stick with discrete since it's the simplest. So, but just a rule of thumb, use discrete whenever possible. If you have fast moving objects that often collide with stationary ones or static ones, use continuous. If you have a fast moving object that interacts with a rotating object, use continuous speculative. And if necessary, if you have two moving objects that will collide with each other, then use continuous dynamic. Rule of thumb. So discrete, continuous, speculative, dynamic, in that order. So now you guys should be able to look around in all directions. Now let's go into movement. So what you want? So let's again right click under your scripts folder, create C# script, and name it something relevant. We're making player movement, so I labeled it player movement. Now this one is fairly lengthy because this is the final version, but again, it's honestly not too big. It's 200 lines of code. Okay, so let's break it up into pieces. First thing that you want to do, again, I assume you're just copy pasting here. Yeah, assume you're copy pasting off of the GitHub link. It's much easier. So you'll have a couple variables here that we'll need. Walk speed, which actually no, all you need is move speed, ground drag, and orientation. Orientation works the same as before. Move speed will determine how fast you move, and drag is something that I'll explain more in detail later. Essentially, it tells you how much friction you have with the ground. Okay, so first things first, here's how I'll explain it. So we have two functions that we're going to make here, my input and move player. Okay, in my input, first things you're going to do is get the inputs for basic walking movement. You want your horizontal and your vertical. Horizontal is up, down, left, right. Vertical is jumping, and that's what you do here. So the horizontal input that we have will get the input from our W, A, S, and D keys. That's what these are. Wait 1 second, where'd they go? Okay. Yeah, here. Horizontal and vertical input. This part here, this all works only after we implement jumping, so I won't go over it now. Now under move player, this is another thing. So it makes sure you move in the direction that you're looking in. So often FPS controllers, the way they work is wherever you're looking, that's the direction you'll move. So technically you can walk in every direction by just holding forward and then moving your mouse around. But sometimes you want to be able to move left and right or backwards without changing where you're looking. So that's where A, S, and D comes. So what you want to do is move direction, you get your orientation in the forward direction times your vertical input plus you're moving right and left and your horizontal input. Now we're doing specifically right here because it doesn't really make a difference. You can do orientation dot left or dot right. Right is left would simply be a negative value for right. Think of these as values from -1 to 1. 1 being completely turned to 90 degrees to the right, and -1 being looking at the left. So anything in between is your angle there. So it doesn't really matter. Vice versa, left would be 1 being 90 degrees to the left and -1 being 90 degrees to the right. Slope movement, this is all stuff that I'll cover later. So once you implement these parts, 1 second. Okay. So once you do that, you can save your code and get it running and you can test it out. But what ends up happening is here. So what you'll have is, then you'll also need to add this part here, not the else if, simply just add rb.addForce. RB is what acts as your rigid body. So you'll have these two parts here. Vector 3 is just a variable that stores the vector in the three axes. Rigid body is what you'll be applying any physics to or any motion to. So that's why I asked you to add under here. You'll add your rigid body. This RB variable here will get access to this rigid body. So here, okay. Now let's, yeah, here. So there's a function called add force where you'll add force in move direction, which is wherever you're looking. Normalize so that it's a value. The magnitude becomes 1. Okay. Times your move speed. So depending on how fast you're moving, that's how much you'll add force. 10F is just so that you don't use arbitrary values because by default you do like things like 200 for move speed, and as a force 200 seems like too big of a number, so we multiply it by 10 to make it more visually sensible. Then you have force mode.force. This just specifies how you want to apply your force, the different types like impulse, force, linear, things like that. Don't have to worry about it. You can look at the documentation if anything. So we're using a force. Now that should get your basic movement up and running, and you can simply move around. But what you may find is that you build up speed, and then if you let go of the key, you'll still keep drifting in a certain direction, and it's like you're on ice basically. So obviously you don't want something like that unless that's the kind of game you're going for. So we have to implement drag. So that's where ground drag comes in. Where did it go? Here. Okay. So, 1 second, ground drag. The actual value for ground drag will set in the editor itself. Cool. See, here is where we check the drag, and we basically apply the force of the drag as a counter force to, or it'll act as friction to our player, and that'll make movement a little more smooth. Now we've got we can move on to jumping. Okay, so the way jumping works is you simply add a force in the y direction as a vector, obviously times whatever horizontal input you're doing and wherever you're looking, but that'll work seamlessly with how we're doing it. So two things that you need to do. First, you'll only be able to jump if you're, well, on the ground, because you can't jump in the air. So this is what is known as a ground check. It's very common in games. So we'll need to do two things. 1 second, move speed. So you'll have, sorry. Excuse me. You'll have your jumping header. So here, header simply means that when we open the script here, you'll see, like, so this is in movement, this is for jumping. It just lets you organize your information. So you'll have four rather. You'll have the force of your jump, so how much force is there in your jump. Jump cooldown, which lets you dictate how often you're able to jump. Your air multiplier, which lets you dictate how much control you have in the air while you're like falling down. And a boolean, just to check if you are in a state that's ready to jump. So what we'll do is we're going to perform what's called a ray cast to check if you're on the ground. So in order to dictate how many times you can jump, you have to first check if you're on the ground. So another thing that we have to make is, okay, first let's just do jumping, right? So you'll have, let's make another header named keybinds. You'll have your jump key, which is set to space here. We'll look at the other two later, but most importantly this line here. Then, one second, my input. Okay. So the reason this looks a little messy is because this has everything in it right now. This is not what it used to look like. So oftentimes what will happen is you'll implement something, it'll work as it is, and then you'll add modules to it. It's just a principle of programming, and you'll change how the code works. So here, okay, this is all that's not necessary. So under my input, you'll just have the thing that checks if you are pressing the jump key and you're in a state that's able to jump and you're grounded. Then, so first you'll set ready to jump back to false, so you're not able to jump then, and you perform the jump function. Now let's look at our jump function. Here, it's very simple. So we'll just do rb.velocity and we'll make a new vector. X and z remain the same. Okay, no force on top here. Okay, and then we'll add the force to it. So we'll look at the up direction. So we'll go to transform our player's position in the up direction, multiplied by our jump force. So the higher jump force, the more we'll travel in the upwards direction. And then you have impulse. Impulse is like an instantaneous force, so it's not a continuous force. Force mode.force, like we mentioned earlier, that's why you keep accelerating. It's a continual force. It's not one instance of it. That's what impulse is. So here, this is a jump function. So whenever we press the jump key, we'll call this jump function and move in the y direction. Yeah. The reason this has zero force in the y direction is because this is simply just to like have your air control. This is actually adding the force to it in the y direction. Okay, Now let's perform our ground check to see how often we actually can jump, and that's the raycast here. A raycast, excuse me. Okay, so we've done all of this. We've made a player, we've added basic camera movement, we've added a rigid body, I explained your different collision types here, collision detection types. We've gotten basic X and Z movement, so that's what this is. This raycast here is what I'll explain now. Okay, so a raycast is basically you're casting out a ray, or you're shooting out a ray from a point and checking if that ray ever hits or interacts with an object. If it does, it'll return true. So it's a function it's built into Unity. So this first part here specifies the origin. So whatever position that the object is from, that's a position it's going to use. The direction is down, so we're checking beneath us if there's anything there. And how far we want it to go is this here. So the player's height, okay, times 0.5. So half of the player's height times a little more, just in case the ground has divots or anything like that. And what you're checking for is what is ground. So what is ground is actually a layer mask here. Okay. So under ground check, we're going to look at these three things: player height, which sees how tall the player is. Layer mask is basically it's a way of identifying a certain layer. Okay. That tells you, and then you'll have a boolean that tells you if you're grounded or not. So the way that works here is, now what I want you guys to do is all of these objects here that you see, save perhaps the cube. Okay, under layer here, so you click on the object, under layer you'll go to add a layer. Okay, and I've added one called what is ground. Okay, once that's done, go back to this here layer and make sure it's selected as ground, not default what is ground, because otherwise if we make an object here, for example, this one isn't labeled what is ground, right? So okay, let's just take this for example, this one here. Let's remove the fact that it's a piece of ground. Now what's going to happen ideally is I can jump normally, right, in whatever direction I choose. If I jump on this, however, now I can no longer jump. I'm hitting the spacebar and it's not jumping. That's because according to Unity, this isn't ground, so I'm not looking at, I'm not on the ground. Hence why here this grounded boolean is unchecked, which means it's false. As soon as I touch the ground again, I can jump and it says I'm grounded. If I jump on this, however, it's not. So that's how our ground check works. So we must label this as ground. So go here, default, what is ground? One thing that I should mention, if you hit play, so if this button is blue here and you're interacting with your game and you change certain settings, once you leave play mode, those settings will revert back to their original. So make sure your any changes that you make, either remember them so you can apply them after you leave play mode, or change them before you go into play mode itself. Okay. So yeah, that's our setup. So we cast the ray. If it hits something, that means we've grounded, right? If we jump, then the ray won't be long enough to touch the ground, so it doesn't count that we've jumped. Remember, every update you want to call the myInput function, so it gets the inputs for your walking. You won't have this part yet, so, or if you copied it, you would. Now, here, this is what you need. So, this checks if you have pressed the jump key, so this detects for input, remember, and you're ready to jump and you've touched the ground, so you're grounded, which means lets you allow. We will call the jump function, like I said earlier, set this back to false, and invoke reset jump cooldown. Invoke is basically, so methods are called as soon as they're the conditions for them are met, right? Invoke lets you call a method at a specific time. Okay, so we'll call this reset jump function. So reset jump here, yeah, this reset jump function, which just basically sets ready to jump back to true. Exiting slope, I'll explain later. That's all this does. So normally it's false, right? But every time reset jump is called, it's true. So we go back here. So this will call the reset jump function at an interval of jump cooldown, which is like how long it takes for our jump to be available to us again, right? So what this allows us to do is hold down the jump key and keep invoking that that jump command whenever we're ready. So I can simply hold down space, because normally in most controllers you hold on space, it'll jump once, but here it'll continually jump, which maybe that's not to your liking. But what that allows us to do is if we have to make rapid jumps, or for example, it helps a lot when conserving momentum. So for example here. So if I'm crouching and I gain speed, sure, I can walk really fast, but it lets me conserve more momentum if I keep jumping rapidly in rapid succession. So here, and it allows for longer jumps, and then slowly dissipates as we go. Okay. We'll also, yeah, we went through this. Okay, now once you've done that, save your code, go here and add the player movement skip. So same way as before, so search add component and just search movement skip. Okay, then you'll add these settings. So your walk speed should be 7, you won't have this. Orientation, grab this orientation and put it in here. Ground drag set to 5. Your move speed should be 0. This is just to check, to monitor your move speed. Don't ever change this variable. These two you won't have. Under jump force, make it 12. Jump cooldown 0.25 seconds. And air multiplier 0.4. The lower you make this, the less control you have in the air. For example, let me show you here. So if I jump, I can move. So I'll press jump and then move to the left instead of doing them together, so holding left and jumping. For example, if I'm moving to the left and I want to jump to the right, so moving to the left, jump, and then move a bit to the right. How much I get to move is determined by this air multiplier here. So if I when you see those two side arrows, I can increase it. So if I increase it to 2, for example, now when I jump, I'll have a lot more air control. So if need be, I can like even zigzag in the air, right? However, one second. If I increase it further, let's see, to some absurd value like that. So you see this? I have a lot of force that's applied in whatever direction I pick while I'm in the air. So the actual force of the jump is not strong. So you'll see it makes a weird jerking movement. So if I jump normally, it's a regular size jump, but as soon as I put an input, I shoot off in the direction. So I have a lot of air control. Obviously that's not realistic, and if I make it 0, then I won't have any air control. So if I'm walking to the left and I jump, I won't be able to move to the right at all until I touch the gun again. But this is how it is realistically, but we don't want that, so set back to 4. Or actually, even if I made it 10 here, sorry. Let's see. Okay, I made it 10. As soon as I leave play mode, it's back to its original value. So it helps there. So it's a good way to test out stuff. So yeah, you should be able to move. Your ground check. Oh, make sure that under this, make sure you press the what is ground layer mask. So that's why we made this. It takes in the what is ground layer mask, Player height, make sure you set it 2. The reason I know it's 2 is because these values here are arbitrarily chosen. You can change them however you'd like to customize your game. But player height, the reason I chose this is because under capsule, you'll see that the height of the capsule is 2. If I change it, then I would have to change the player's height as well. Cool. And then you should have your keybinds. For now, you should only have your jump key. Your space, you can change that however to whatever you want here. That's this part here. Yeah. So key code makes it expect a keystroke, which is down normally, and then you can specify what it has there. Okay. Now we've implemented basic like movement, walking and jumping. In a lot of games, that's about it. For example, Counter-Strike, CSGO, that's all you can do. You can move around and jump, right? Your movement speed is tied to what gun you're holding, and they'll each change it differently. However, if you want to make a movement shooter, like I mentioned earlier, you give more focus and movement becomes a bigger part of your game. The next thing that you want to be able to do is crouch. Now, for example, your terrain, you no longer interact with your terrain in a static way. For example, if, say for example, I want to move around this corner, right? Now all I can do is, this object is here. All I can do is move my entire player around to look around this corner, right? If I'm here, all I can do is just stand here and hope that whatever the enemy can see, for example, if there's an enemy looking at me, they can see the top half of my body. So sure, it's a lower area that they can see, but I can't really interact with it. Here, what I can do is I can crouch. So crouching lets you dynamically interact with your environment. If I want to look around the corner, I can look so. If I want to peek over the top, I can do that. Obviously the height of this is a little different, but I just made it for a test environment to see if crouching works. I can fit into tighter spaces, perhaps hide from things, or maybe ambush, whatever it may be. Those change how you interact with the environment. So let's implement crouching now. So you want to make the variable for that as well. Where is it? Here. So let's make a crouching header, and then we'll have crouch speed, crouch Y scale, and start Y scale. Reason for this being is you basically squish your player model down, and that becomes your new model for crouching. So you can fit entire spaces, as well as your speed being decreased because you wouldn't move quickly if you had to crouch. Okay, 1 second. Okay. So under input, this is to detect whenever we've crouched. Before that, remember at the start, let's make our start Y scale whatever our current scale is. So because once you squish down, if you let go of your crouch key, you want to be able to go back to your normal size. You don't want to stay in a small state. So that's what this is. Whatever your current size is, your Y scale size, you set it to that. So Y scale, remember these as well. Freeze rotation basically freeze rotation lets you stop tumbling over, basically, because you're putting a force, so you can freeze that rotation. If need be, you can do it through script, but you can also do it through here. Under constraints, you can freeze rotation in the XYZ or the freeze position, but we're doing it through code. Just a moment. Okay. Platforms, okay. So jump and set Y scale. So whatever the local scale basically means your whatever position this script, whatever object this script is attached to, it'll take that object scale in the Y direction. Then okay, that's already done. On drag we've implemented. Okay. Another thing that we're going to need to do is make movement states so we can switch between them. A player can be walking for now and sprinting, crouching. Those are two movement states. So add those two, crouching and walking. Okay. We also add sprinting. I'll explain sprinting simultaneously. Then you're going to move on to the state handler here. Now this will tell us what we're going to do whenever we switch from one state to another. So, okay, the is sliding part we can remove. Now if we're crouching, okay, if we input the crouch key, we'll make our movement state crouching. Okay, so now whatever the player's state is set to crouching, and our move speed, whatever our crouch speed is set to. So remember we had the crouch speed in this section here under crouching. So we can set that the actual speed, the value in the editor, but we make it a crouch speed. If we're sprinting, we'll check if we're grounded because we can't sprint in the air, and if we're hitting the sprint key. In that case, same thing as before, make it sprint speed instead. Okay, and set the state to sprinting. Walking is just if you're just grounded, you'd be walking, and your walk speed would be your move speed. So you have the move speed, and the move speed is changed depending on what state we enter. So if we're crouching, our move speed is now our crouch speed. That's what the target move speed is. Okay. In the air, you have a different speed in the air, and that's your multiplier. I'll explain that after. Okay, so now you would have to have a speed control. So when you sprint or when you walk, you might notice that that you start to go faster than you've intended. Even if you're, like for example, if your move speed is 7, you might move all the way up to 10, even though you've set it to 7. What you need to now do is implement a speed control that limits how fast you go. Sorry. So here, what you do is you'll take the flat velocity of your vector, okay, so you'll take the x and z position, not the y because this isn't jumping, and you'll check if your flat velocity is greater than whatever your movement speed is. So whatever your set movement speed is, if you're traveling at a speed higher than that, you'll limit your velocity to whatever your move speed is, and make sure that you're only traveling in that velocity. So that's what this part is. It makes movement a lot more controlled. Okay, crouching should work the same. Speed control. This is only on for slopes. Yeah, so because we added the states, we don't have to actually change how our move player function works. As long as we're getting the input and we know what the player is inputting, we can change the state, and this remains largely the same. This part here basically sets it to where if you're in the air, the force that's added to you is dependent on the air multiplier. So if you're not grounded. Okay, so here is the whole changing your size. So if you press down on the crouch key,
you'll make your new scale the crouch Y scale, and you can set that, you normally just want it to reduce by half, so in the editor you can set it to 0.5. So you'll set to crouch Y scale and you'll add a force. So now let me explain what we're trying to do. Because we're crunching up the player, right, your player will become shorter, like up till here, right, but it will reduce it in both sides until it's half its normal scale, and what you'll have is a floating player, okay, since you crunch it from both sides, so it won't be touching the ground. This line of code here basically adds a small force to push you back to the ground, okay, so it moves the player down so they aren't floating when Y scale changes. So in the down direction, you'll add a small force for just an instant, just to move you down to the floor. So you're now touching the floor, and then from there, if you let go, so this is on crouch, if you're releasing the key, you'll move back to your normal Y scale, so the normal length of the player, and that's basically it. Sprinting is largely the same. If you press the sprint key, your movement speed increases. That's it. Okay, now let's handle slope movement. Okay, so your game isn't going to be a flat plane. You're going to be moving up and down through obstacles, right? Sometimes they might be at an angle. So if you didn't implement slopes and you tried to move across here, for example, what's going to happen is, say I'm moving at speed, like a speed of 7 units, okay, an arbitrary number, unit. When I move up a slope, it'll slow me down, okay, and now depending on how steep the slope is, I'll slow down even more. So if I was going against this slope, I'll slow down. Obviously here it's not working because I've implemented slope movement, but that's how it would work, and it'll go even slower here. So reason for that being is your force here. When we add a force, it goes in a straight direction, right? This is so we added in a vector 3. If you remember, the add force was in a vector 3. So this is your normal, and this is your regular direction, right? You're moving into the slope's angle. So the resultant force is just slowly inching forward. What we want to do is be able to apply a force parallel to the to your plane. So if my slope is 10 degrees, I want to move the angle of my force 10 degrees up. So now I move in that direction, so it doesn't slow me down. For that, we have to just figure out if we're even on a slope. And now there are multiple ways to check for that. You could add another layer mask to see if that's the case, but we can only ever add one, remember. So we're keeping it as ground. So instead, what do? We can write code that checks for it. Again, very similarly, we're going to perform a raycast, okay, here. So this function on slope checks if I'm on a slope. It's going to perform a raycast similarly like the ground check, and see if I've hit there. This slope hit basically takes the direction of stores the information of what I've hit, of what object it's hit. So 1 second. Slope handler, where is the slope handler? Okay, so up here, under slope handler, we make these 3 variables, okay? Max slope angle, so obviously you don't want to be able, like, it's not realistic to climb something that at 40 degrees in itself is actually pretty unrealistic, climbing up 40 degrees. But we don't want to do, we can set the maximum angle we can climb through. Then slope hit here, which is of type raycast hit, which basically it stores, whenever a raycast hits something, it stores information about that object. Like its collider type, its object type, like things like that, what position it's hit at, and different things like what polygon or triangle it's interacting with within the shape. Very internal stuff, you don't need to know as of now. And then a boolean that checks if we've exited the slope, so if we're not on a slope currently. Now, so on slope, where is it? So it'll check that, and we can then check the angle that we're currently at, right? So in order to move our force at an angle, we first have to know what angle the slope is at. So we'll get vector3.angle in the up direction and check the slope hits normal. So that's one of the things that it checks is a normal. Normal is basically the perpendicular direction of any given surface. So if this is my surface, this would be its normal, and it change depending on that. This is just some debugging I was doing to see if it truly did return the angle. And then you can check here. Now what you want it to return is if the angle is less than your max slope angle and it's not 0. So a flat surface shouldn't count here. By angle we mean anything greater than 0. If it's not flat and it's smaller than our slope angle, then return true. So it's a boolean function. It returns true if we're on anything that's between 0 and the max slope angle. If so, we'll use this function here, get slope move direction. So it changes the forward vector of our force into whatever angle we stand on. So we use this function here called project on plane, which is basically a fancy way of saying we take the normal of something and then project a plane in that direction, and we can use that whatever's been projected as our new vector for the force. So we'll take in the direction of where we're moving. Sorry. Okay. And then project on plane, the direction, the slope it. Remember, it needs to be normal. And then this normalized, normal means like the 90 degrees angle. Normalized means that you set the magnitude of any vector to 1, because a vector shows two things, direction and magnitude. Magnitude is always set to 1, so it makes it easier to work with, so we don't have negative numbers, for example. Okay, once we do that, now if you realize, if you did this if you implement just this part, you would slide down slopes because gravity is pulling you down. So what we want to do is we want to disable gravity whenever we're on a slope. So in reset jump, we'll set this to false, and where is it? Here. Yeah. Whenever we're on a slope, so if we're not on a slope, we'll use gravity. Okay? But this works fine because as soon as we leave a slope, gravity will be turned back on, and that's where this part comes in. So if we're on a slope and we're not leaving a slope, so the boolean is false, we'll add a force in the force's direction. So we'll use get slope direction to see the direction of the slope, okay, and we'll apply a force onto it, and that's this part here. Again, this part here, is if our velocity, so if we're moving up, okay, a little more physics to explain to you. When we move up a slope, it will be faster than normal, because this is where Pythagorean theorem would come in. We're moving, say, 7 units in this direction, right? Now, if we're moving upwards, we have to travel a further distance within the same amount of time. So what ends up happening is the game will automatically increase your speed, so you're moving the same distance within the same time. We don't want that to happen when we're on a slope, because it doesn't make sense. It acts like a weird speed boost. So what this does is, again, it limits your control. So if you're going in the up direction, then you'll add a slight downward force to keep you in place. And under speed control, same thing. If we're on the slope and our velocity's magnitude is greater than our move speed, then we'll change it back here. Key, speed key. Raycast. Okay, the sport's done. You guys know how my input works. Okay, so this still allows you to jump on slopes essentially. Under speed control, the exiting slope still allows you to jump on slopes and have gravity while on a slope. Okay, now let's move on to sliding. Okay, so that's another part that's very famous in movement shooters. All the ones that I mentioned earlier, Doom actually I'm not sure, but Apex Legends and Ultra Kill, those both have it. So like I mentioned earlier, we'll go here, make a new script named sliding. Let's open it. This is what our sliding script looks like. Okay, we're going to have references to our player movement script. Okay, so we'll have its orientation, the player object, a rigid body, and a reference to the player movement script itself, so we can get variables from there. Sure, we could make it public and do it that way, but that's bad practice. So under sliding, we have three variables. Max slide time, so how long you can slide for, because it doesn't make sense to infinitely just keep sliding. The force of a slide, so how quick or how much force is applied when we slide. And a timer that just checks how long it's been since we've pressed the slide key and if it's over this max slide limit, stop sliding basically, or once it reaches the max slide limit. And then you have your inputs. In this case I made left alt. You can change it to C or control or whatever you like it. Okay, under start function you just want to instantiate these your player movement script and your rigid body, and you want to make sure that you're again, because you're sliding, we're going to treat it like crouching, except we have forward momentum. So we're going to move. We're going to change our Y scale of the player again. So we're doing that part. So again, make sure that your starting Y scale is just what your player normally is. Under update, you'll get the normal functions, normal inputs. That's, you know how that part works. Now we'll make two functions: start slide and stop slide. I'll get to sliding movement in a bit. For start slide, we'll see if we are sliding. So from the player movement script, if there is sliding variable is true, I'll show you. We're gonna carry over a few things there as well. I didn't show you when it was made. We're gonna change the Y scale to slide scale, which is again same as crouch scale technically, and add a force to move it back down so it's not floating in the air like last time. And then we make our slide timer whatever the max slide time is. To stop slide, we simply set it back to false and set the Y scale back to normal. Now in sliding movement, what we do is we'll get the input direction and move it forward for the vertical and left and right for this, like it was in our walking movement. And now we have two types of sliding. On the ground, if we're not on a slope and we're moving upwards, okay, that's what this part is here, or we're moving upwards, not and, sorry, we'll add the slide force and we'll start decrementing our slide timer and to see if it reaches the slide timer. Okay. If it's not that, then we're sliding on a slope. So this will check. Basically, if we're going down a slope, we won't have a max slide timer because gravity is pulling you along the way, right? So right? So what we do is we have an unlimited slide time. So a player can continually slide and keep moving downwards. So that's what this part is here. We get this, and in order to add our force in a direction that's a slope, that's what this part is here. Yeah, greater than or equal to 0, stop slide.
And have we fixed update since? Okay, so fixed update I should explain to you. Update is called every frame. Fixed update is called every certain interval. So by default, I think it's 0.02 seconds. So sorry, 0.02 seconds. Fixed update is called, and it's at a fixed point. Reason for this is, say I develop my my application on a very powerful computer. So the update function is called once every frame. My computer runs at 60 frames, 120 frames per second because it's very powerful. And I publish my game. And now someone with a slower system might run at 30 or 60 FPS. So everything that I've designed that works and feels good at 120 FPS will feel sluggish and like unplayable at 60 or 30. So whenever we have anything physics based that we want to do, every time we use fixed update instead, because regardless of how good my system and how good a system is, it'll be called every 0.02 seconds. So there's a fixed time the update is called, basically. So if you want to use anything physics related, we use fixed update. So here we'll do the sliding movement function, and since this is adding force, which is a physics-based movement, that's where this comes in. Now going back to our player movement script, 1 second. We'll add another state. So we had walking, sprinting, crouching, I didn't mention it earlier, but air as well. Now we'll make a sliding movement state. And under our state handler, so we have these, which was normally there, okay? And then we have our state, our sliding part. So we set our state to sliding. If we're on a slope and we're moving downwards, then we'll get a slide speed. Else, we keep it a sprint speed, okay? So now what we're going to implement is momentum. This is the part that lets you gain speed as you're going down a slope, because you have like gravity acting in your favor, and it opens up a lot of movement freedom. Okay. So what we're going to do is we're going to make a coroutine. A coroutine is a function that doesn't complete its entire state in each call. Instead, it'll save its state and finish the function over multiple calls. So what we need to do is, the way momentum works is it's not an instantaneous change, right? So if you're sliding down a slope and we then hit the sprint key, we don't want to have a tremendous amount of speed and then suddenly drop down to 7. That's not how momentum works, drop down to sprint speed. We want to slowly change or lower our speed until we get to our desired move speed. That's why we have these two variables here. Yeah, here. Target move speed and previous target move speed. You can think of them as desired move speed if need be. So we're going to use lerping, or what's known as linear interpolation. So basically it's a math term where you'll interpolate something based off of, like on a linear time scale. There's also cubic and other forms, but you can think of it as a graph. So since linear is a straight line, each time
you interpolate, it would move by a fixed distance.
Okay, so here in this function you don't have to worry about why things are done basically, but you'll have a time and you'll check the difference. So if a difference is greater than a certain amount, then we want to move slowly. Otherwise we can, so for example, if we're moving from walking to crouching, we can do that instantaneously. It doesn't need to be like a slow, because then it makes the movement feel sluggish. You want to still feel like you're in control of the character, but not to the point of where momentum doesn't exist, because then it doesn't feel rewarding. So if the in this example we're making the difference 4. So if we're moving from crouching to from sprinting to crouching, there's no interpolation. It is an instantaneous change. But if it's larger than that, we'll take the absolute value here, check the difference. If the difference is greater than what we want it to be, we'll slowly decrement it. Okay, that's basically what it does. You don't have to worry about anything else. Then here we'll check. So if our previous target speed and our current target speed is greater than 4, this is where I decided it, and our move speed is not 0, of course, then we'll start the lerp coroutine. Otherwise our movement speed is whatever we want our movement speed to be. And yeah, last thing that we want to implement is multipliers. So the speed and slope multiplier, that basically means depending on how steep the slope is, we'll go faster or we'll gain momentum quicker. So the closer it gets to a straight fall, the faster we're able to develop our speed, and that's basically what that part is. So it's pretty, yeah, that's where this part comes in. 1 second. Yeah. Oh no, it's air multiplier. No, man. Yeah. Under this part, we add the small part here. So so we'll keep adding to our time. We'll check the angle of our slope increase, and if it's steep, then we increase our multiplier. If not, then we keep it the same. So 1 second. Wait, before I move to that. So yeah, that more or less covers how I've made this controller. You will have to look at a bit of documentation. So for example, let's look at it here. Okay. So these are the values I set my scripts to. So this is the jumping stuff here. Under sliding. 1 second. Okay. For references, make sure you have these two things. Player object is just your capsule, the one with the collider. Your max sliding time, you only want it to be 0.75 seconds. You could make it shorter, that's up to you. So I kept it at, so it's a reasonable distance. You can still cover a lot of ground with it. Slide force is 200, so I want it to be faster. So you could combine it with jumps. Perhaps it's a bit too high. I'm not really good at this sort of stuff. Yeah, and then you have your Y scale. So if I just press C, or which is my current input, you can see here, I can set it to back to left alt, but I prefer it at C. If I just press C, which is my sliding button, nothing happens. I need to be pressing W, A, S, or D, and then only I'll slide. So here, otherwise it doesn't work. Otherwise you'd use crouching for that. You can set it to the same binding. So if you're moving, you'll slide, and then once the slide time is done, you'll move to a crouching state. If that's what you want, then you can do that as well. Now let's show you the momentum thing I was talking to you about earlier. Oh, so look at this move speed. By default, when I'm walking, it's 7, right? If I press shift, it's now 10, so I moved faster, right? If I press crouch, it moves to 3.5. So
these buttons dictate how fast I'm moving. Let's go here. It looks bumpy because I'm holding the jump button. Okay. So now if I crouch, as you can see, my move speed goes to a very high degree, and then as soon as I get off, it slowly moves down to whatever I want it to be. As it slowly goes down and returns back to my crouching speed. If I was sprinting, so here, get a lot of speed. If I go up something, as you can see it, and now it stops at 7. If I go to a less inclined or something with a not as steep angle, and I go to develop momentum, you see as it's not as high, and it doesn't gain it as high either. Additionally, if I try going upwards, it'll cut my momentum way faster, and I wanted to do that because you're going against gravity, right? You can see how much air control I have here, and as soon as I start going up this, it'll cut it immediately, or start reducing it by a lot. The only real, I'd say, weird part about this is when I'm sliding and I have to gain my momentum, I can hit the crouch key and I'll still be moving incredibly fast. Ideally, you want crouching to be very slow, so you could just kill the momentum, but I decided to keep it this way. And if you let go, you get stuck. You can't move around. You have to be holding the crouch key in order to move it. And yeah, that's basically the controller I've made.
It's pretty bare bones, but that's on purpose so that you can take this code and you can add it to whatever game that you decide to make. Obviously, you can change a lot of these things. So if you and you can change the functionality as well. Computationally, it's pretty light. Yeah, and this test environment is pretty, like, it works as well. Next time, I'm probably going to be adding animations, projectile launching, and several other things. So yeah, stay tuned for that kind of stuff. Thank you so much for your time, and I'll catch you guys next time, or for the next Unity session, or the next week.